see and hear me, which is great. Thank you for the introduction, Joe. Great to see at least a few people attending this webinar on the topic of factory scanning and virtual twins within the manufacturing domain. My name is Daniel Wigren. I'm the head of sales and marketing for a company called Virtual Manufacturing, based and headquartered in Gothenburg in Sweden, but working with the world as our footprint, if we put it that way. I'm also hoping that the most of the attendees today have some kind of a connection to the manufacturing industry or to some kind of warehousing or logistics industry. I'm very pleased also that a long and good friend of mine, Reto, will be presenting some showcases that he, or some projects that he's been involved in on the topic of virtual twin. After this, I'm hoping that he will join in time. So let's kick it off. And I think, Joe, when it comes to questions and stuff like that, we will summarize it and have a little Q&A session at the end, which will be perfect. Right. Just a few words on Daniel Wigren is my name. I've been in the manufacturing, production, internal logistics development industry for about 30 years. Have had the opportunity to work towards a lot of different organizations, and both large within the automotive and the aerospace and defense, and so it's been quite different. And the topic of today is what we call realizing the benefits of factory scanning and virtual twins in manufacturing. And just before we kick it off, I just want to sort of set the ground a bit, and I mean, there are a lot of buzzwords circulating nowadays in this industry on the topics of digital twin, virtual twin, digital shadow, and so on and so on. And just before we kick it off, I just want to bring you back a bit, or just look a bit at what is the actual see if get this. Yeah, what is the actual research topic that we're discussing or that we're looking at? So there is a lot of research going on in this area. Universities all over the world are looking at, what are the benefits of virtual twin, digital twins? Is it for the product development industry, or is it for the manufacturing industry, or is it a combination of both? And with that said, let's just get some of the actual namings in place before we start, or before we proceed with the presentations. We have something, and the main topic here, I would say, it's not really whether you're looking at a physical object or a digital object. I would say that the different levels have more or less to do with the automation of data that is being transformed, or that is being pushed or pulled from the physical world to the digital world, and vice versa. In other words, how are we populating data, real-time data, into the digital object of the physical object? So the physical object is typically some kind of a manufacturing facility, some kind of a factory that we have. The digital object of that physical object is some kind of a digital model. Exactly what the digital model looks like, whether it's a 3D CAD model or whether it's something else, it's sort of up to the user of the digital model to define, and also up to the company itself to define. In other words, what is our definition of a virtual twin? And trust me when I say there are many different definitions. So just on the topic of, digital model, what is a digital model? Yes, we have a factory. I hope you can see my pointer here also. We have a factory. We have a digital object. In other words, we have a digital representation of the physical factory. No problems around that. Has been around for a long time, more or less since the whole CAD industry was invented, and we're talking mid-early 90s. In other words, we are visualizing our factory in a 3D CAD world, where we can work with planning, layout planning, where we can work or we can visualize our different flows in the factory, material flows, and so on and so on. The next step is then when we start looking at a digital shadow. In other words, where we're actually automatically pushing data, real-time data from the physical factory that we have into our digital model. That's sort of like the next level. And then the third level, the true definition of what a digital twin is actually is according to research, is when we are automatically pushing data from the physical factory to the digital factory, and also delivering data back from the digital factory or from the digital object to the physical object. So I hope this makes it a bit clearer on where we are today. What is the research saying? Where are we heading in the future? My personal opinion is that when it comes to digital models, I mean, that's something that we've had for a long, long time. Where we're heading is definitely on the digital twin direction. I mean, I think it's a lot of progress is being made when it comes to different technologies that are being developed and so on. A lot of different companies are involved, but I think it all comes down to that we want to have a one-to-one copy between our physical world and our digital world, and when we have that, we can actually start sharing data between those two worlds, and hopefully in one way or another improve the businesses that we're running. So that's sort of the background before we jump into a bit more details on this. And as I said, there's a lot of research going on in this topic. There are some universities, colleges around the world that are leading the way and that are really pushing the boundaries of what can be done and what cannot be done and so on. And I think we have an extremely interesting time ahead of us on the topic of digital twin. In other words, where are we heading? But with that said, let's just continue a bit and look at, or maybe take the context of digital twin into something that we see every day. In other words, that we as consumers are more or less looking at every day. And I like to share, the story of Google Maps. I mean, Google Maps is more or less, I mean, it's enabled by the fact that we have, or that Google actually have satellites up in space, and they're continuously updating what we call the mirrored reality. In other words, they are publishing a mirrored reality in real time of the world, more or less. In other words, we can have the whole world with maps and everything in our pocket on a day-to-day basis. That's great. That's fantastic. In other words, we can actually see the picture of the world. But on the other hand, if we as consumers want to actually get more benefit out of that, we have to add context, or we have to add data to that mirrored reality. And what I mean by that is, when it comes to Google, I mean, they have added different types of layers of data, such as content, such as navigation, such as real-time traffic and information, that actually makes this a very, very powerful tool for us as consumers when we are, for example, driving from place A to place B, and we can actually in real time see, is there a collision? If I take left, if I take right, what is the fastest way for me to get from point A to point B? And I'm sure this will evolve even more. Now, what's great, or what's great about Google Maps is the fact that it is, it's uptime, it's available for everyone, and the only problem is, or the only dilemma for us working in the manufacturing industry, is that this is for the outside. In other words, as soon as we get inside the workshop, we don't see this anymore. All right. So that's sort of the background. So I think on the topic of digital twin, what many companies are trying to do is something very similar. In other words, we are trying to work on a platform base. We have different contexts or different layers of information that we're adding, but everything is based on the first layer. In other words, the mirrored reality. In other words, we need to see our factory as it looks today, or at the time that we're actually performing the 3D scanning. On top of this, you can then add information. What type of information can you add? Sort of up to you. I mean, there's a lot of possibilities to add information. It could be static information. In other words, you're just showing information or visualizing other types of information. Or it could be dynamic data. In other words, where you're in real time pulling data from other systems and visualizing this. Or you could visualize other types of information. So a lot of information can be visualized. And with that said, there's also a lot of potential users for this. It might not necessarily only be, the engineers in the workshop working with improvements, but it could also be, roles such as working within the facility management, roles working within HR. We want to have a walkthrough of our digital factory when we're introducing new employees, for example. So this is sort of the background. How does this work? It's no rocket science. It's been around for quite some time, and I think what's great about the technology is that it's getting more and more accessible for everyone, and the fact that the pricing and the time that it actually takes to get something up and rolling is being constantly reduced. So if we look at the mirrored reality layer of information, basically what we're doing here is we're trying to emulate, what the satellites are doing for Google. In this case, we're using, or different types of scanning technologies can be used. What we see on the left-hand side here is one type of information or one type of equipment that can be used to actually capture the mirrored reality. And trust me, there are many different types of equipment out there that can actually be used. What we actually do here is most of the scanning equipment are using laser technology. In other words, we're sending different types of laser beams out that hit different objects, and once that object is returned to the actual equipment, we register a point, and that point contains, typically contains an XYZ coordinate, and it contains some kind of an RGB color. In other words, we're actually working with 3D scanning in a color. The output of this is something that we see in the middle picture here, so down at the bottom. In other words, we can pretty quickly generate a 3D scan of a factory, irrelevant the size, depending on what type of equipment you use. It can be done to an extreme detail level, or it can be done to a rougher detail level. What we see more and more is that you're not only capturing the point cloud, and the point cloud itself is good to capture due to the fact that you can actually take measurements in this. In other words, if I'm sitting as an engineer looking at, for example, a 3D layout project where I want to change the layout to improve efficiency or something in my factory, I need to be able to take measurements. It could be floor space measurements. It could be measurements on where at what level does the ventilation come in and become a problem in my factory, or at what level do we have a crane that potentially can collide with some equipment, or whatever it is we're talking about. What we also see is that more and more equipment is using these 360 panoramic picture images, which is great due to the fact that when we are then looking at the digital world or the digital twin, it becomes very realistic. So if I referred to Google Maps before. If you have ever had the opportunity to jump into Google Street View, it's the same thing. In other words, they are also used in 360 panoramic pictures, so you can actually walk the streets of London, or you can walk the streets of any city and see what it looks like. And that's the same thing, same type of technology that is being used here. One little issue that is still on the market today is the fact that we are at any given point of time when we're actually performing scanning services, we are capturing the world as it looks at that specific point of time, right? So if I do a scanning over a weekend or over a nighttime or something, we are capturing our factory as it looks today. If I start rebuilding the factory tomorrow, the scanning world will need to be updated. And why am I saying this? Well, it's because that I believe personally that in the future, where are we heading? Or my belief is that that the accessibility of being able to perform 3D scanning services will increase. I can just take an example from a well-known automotive OEM. If we're looking at Daimler Chrysler, I mean they typically 3D scan their factories. First, it was once per year because it was costly to scan. Then they're looking at 3D scanning their factories once every quarter. And now they're actually 3D scanning their factories one time every month. And that's because they see the value of having this tool accessible to everyone. Right. Once we have 3D scanned, once we've captured the mirrored reality, we can actually use this data to, for example, create some kind of a digital model, as I was describing before in the research. So from the scan cloud, we can actually not automatically. It's still a bit of a manual process today. We can generate some kind of a CAD world where we can start, planning, doing changes and things like that for engineering purposes. So that's more or less. And for those of you that are working in a 2D world, maybe some of you have your layout in a 2D world. Once we have captured or performed the scanning services, we can actually more or less take a snapshot of the top view of this 3D world and compare, what does the 2D layout look like, and is it up to date, or does it actually picture the reality of the factory as it looks today? Right. Now, if we come back to Google, I mentioned before that they are working with different layers. They're working platform-based. They're adding content. And what type of content do we typically want to add when we're in the manufacturing industry? As we can see down in the right-hand corner, this is the view that we're looking at. In other words, we have our 2D view down in the corner. We have our 3D view with the 360 panoramic pictures. Behind this, we have all the 3D data, so we can actually take measurements if we want to do that. We can also add these types of what we call point of interest. And to the point of interest, we can publish or we can attach information. Typical information that might be attached, manual, wiring diagrams, drawings, purchase documents, could attach work instructions, and so on and so on. But you can also create links to other systems where you're actually pushing data in real time. So I could theoretically see, for example, if I want to look at different KPIs or OE measurements, I could see that OE measurements in real time in my digital twin, if that's something that's. Of course, different types of user accounts can be set up such that you're securing the data, such that only the people that should have access to the data have access to the data. And I think if you're working within a global organization, when you have factories in different parts of the world, this is the fantastic way to actually share experience and collaborate between different factories around the world. Next layer, positioning tracking data. I mean, here we can actually, add a layer of information where we're showing, for example, how parts are being moved and what flow do they have in the factory. In other words, we're depicting or we're showing some kind of a material flow sequence in the digital twin. You could potentially take it even to the next level where you are working with real-time location systems, and you're actually depicting in real time information about different types of assets that are being moved around in your factory. Assets in this case could be anything from people to forklifts to even parts and so on and so on. So if you think in terms, find my iPhone. If you have lost your iPhone and you wonder where it is, this is the same thing. In other words, I could use find my iPhone in a digital twin to locate different types of parts or different types of assets. Safety-wise, indoor routing possibilities. I mean, if you're looking out of a safety perspective, you might have different areas of your workshop where you have, for example, fire extinguishers, or you want to work with different zones in your factory where it's important that you can very quickly find the closest way out if something was to happen, or if you want to inform your colleagues about where are all the fire extinguishers located in your factory. Great way to visualize this. And then last but not least, we have what we call the third-party applications that can be added as a layer. And in this case, I would say that it's more a matter of where do you want to go. There are examples where you can actually connect real streaming with CCTV systems. In other words, I can allow everyone in our organization to actually view a specific TV stream or something like that. I can connect different types of machine in real time, different types of SCADA system, different types of HMIs to actually look at, is the machine running? What is the energy that is being consumed by that specific machine in real time? And so on and so on. Even different KPIs, OE measurements, as I mentioned before. You can also link it to different types of external systems, as mentioned before, on the topic of real-time location systems. You might want to integrate this with, for example, an ERP system, such that you can actually filter out information on which assets you want to view and where in the factory are they, and are they standing still, or are they actually moving according to plan, on time or not on time. Right. So if we come back to values for different types of stakeholders, once again, this is 100% focused on the manufacturing industry and the warehousing industry and the logistics industry. We do believe that, of course, there are different types of stakeholders and there are different types of values. And it's without further ado, I mean, when it comes to production, I hope that I've been able to explain some of the values in it. But I think that also like organizations, when it comes to maintenance, when it comes to facility management, marketing, HR, engineering, planning, health and safety for sure. So these are different types of organization, different types of stakeholders in your factory. Let's see, we have some, great. And just looking into a bit more detail on what could the potential values be. I put a slide together here just to get some ideas on where we think, irrelevant of how you're defining your digital twin or what type of technology you're using, but the values that we see from the market are typically some of these. So within production, easy access to work instruction, real-time visualization of KPIs, go to virtual Gemba, for example. I mean, if you want to walk out on the shop floor, but you don't have access to the shop floor. In other words, I can sit anywhere in the world and walk into any factory that I have access to and do some kind of a Gemba walk. I think for me personally, when looking at bigger projects and especially when you have different stakeholders from different parts of the world, when we're talking about efficiency communication, I think this is a great way to actually collaborate with each other. And I'm hoping and thinking that my friend Reto will explain this a bit deeper afterwards. When it comes to the I mean, where can you actually save, or what kind of money can actually be saved? We've had quite a few companies that have worked with this type of technology, and one thing that is very good is less travel with global organizations. I mean, of course, I'm not saying that face-to-face meetings are good for sure, and then sometimes you have to travel to have face-to-face meetings or to be able to see something. But in many cases, if we just had access to the factory, we can view and we can get answers to our questions by just being able to view that part of the factory. So with that said, I think that the greatest value that this can actually bring is on the collaboration side, and that could be collaboration between internal customers within the same company, but also collaboration with potential suppliers or constructors, or if I have a supplier from, let's say, from China, and I have a factory here in Gothenburg or in the UK, and the Chinese supplier is maybe supplying some kind of an assembly line. Of course, it's expensive to fly back and forth every time, but if I can visualize for that supplier, this is the way, or this is what the factory looks like. These are the areas of uncertainty, and so on and so on. I think you can definitely make your communication more efficient. I think with that said, I'm more or less complete. I think we said that there would be maybe some Q&A at the end of the session here. I'm hoping that. Yep, I see that Reto is online here, so I'm thinking that I will give the word over to Reto, and if there are any questions, let's take them at the end.
Yeah, I was just going to say, if anyone has any questions, feel free to ask at the end, or if you're a bit shy, feel free to put them in the questions, and I'll in the chat, and I'll pick them up at the end of the presentations. Thanks, Daniel.
All right, thank you.
So thank you, everybody. My voice is not the best, but I will give my best. I hope you can hear me. It wouldn't allow me to share my presentation right now. I'll try once again.
Let's have a look. That's probably my end. Bear with me. I'll see if I can work this out for you.
Somehow not allowed to. I'll try it that way as well.
There we go. I can see that now. Can everyone else see that?
Okay. Yeah. Let's go to presentation mode then as well.
Yeah, can see that.
So yes, okay. Short introduction. Who am I? My name is Rito. I've been working with logistics in 23 years, of which I owned 11 years my own logistics consulting company, where I started collaborating also with the guys from Virtual Manufacturing and Tanne. And since 1 year back, I'm working with a startup called Warehouse Analytics. What we do there is we have a digital twin where we combine spatial data in warehouses with information available from warehouse management systems or ERP systems to harvest transactional data, to harvest data from your current orders and from your inventory, and to do several use cases regarding slotting, so better placement of material, predictions on how long your pick rounds will take, if you have enough people in to make your deadlines for the day, and things like that. But we are also working, and I have been working extensively with layout engineering, and we use a virtual twin whenever we do layout engineering, and that's what I'm going to talk about today. So all the other fancy stuff, maybe another time. So I'd like to take up a customer case, typical for logistics consulting. In that case, a company in the mining, producing mining equipment. And we had a task there to make a master plan for logistics development. We based that on data analysis. We then made a gap analysis on the logistics process material flow. And we were asked then to remodel the logistics layout, add storage capacity, and detail a new logistics process. So that's kind of the whole project that we were dealing with. And here you have a glance into one of the possible to be layouts, how it looks like when we're actually working on a layout and layout in engineering in 3D. So that's kind of the end result of the process. But on the way there, CAD modeling in 3D, I think it's really necessary today to do 3D. It's just much easier for people not being used for 2D drawings and CAD drawings of layouts, to really grasp processes, to grasp areas, and then also in the end to be able to explore a layout in VR, in virtual reality, will, especially for warehousing projects, give a good feeling of sizes of areas, of sizes of process areas, storage areas, and so on, which is like really, really good. We have a process that we adhere to when we make such layout projects, basically. So we always 3D scan the factory and the logistics to get a virtual twin of the factory, right? So after the 3D generation, we generate this virtual twin environment where we can walk around, where we can do virtual Gemba walks, and where we can take measures whenever we need to do that. From there, if we are not having any 3D CAD or 2D CAD available, we start building up the walls and the outlines and all the columns in the buildings. After that, we add machinery as a part of the as-is layout. That can be done by basically going into existing libraries that we have, or we can, of course, then make quite simple symbols or machinery outlines very quick. Or last but not least, we can also, from the point cloud, crop out certain parts of machinery that we then can move, like as a point cloud in the 3D model. Just we oftenly use that if we have existing machinery that we are actually not changing kind of layout wise, but that we might move to another place. But then, last but not least, we go into the process where we do layouts, and doing layouts is kind of a process where you take 2 steps forwards and then make 1 step back and 2 steps forward again. So it's very good to make several layouts. It's also very good to make kind of bad layouts, if that makes any sense, because you learn from making, maybe trying something in 3D, you learn from it what's not really working very well. But you also learn what you actually like in other layouts and why you like it. And maybe you have good pieces also from something that you just tried. So it's really an iterative process. And then in the end, when you have maybe 2-3 good layouts with a good process that you can imagine, you have really the possibility to go to VR, which is especially when you come from a project team and go out and have to communicate. You have to communicate to a board of directors and so forth. You have stakeholders maybe from corporate communication, or you have stakeholders from HR and so on that are not technical people. It's of such big value that you actually can go and show things in 3D. So that's kind of the process that we do. And I have one big and bold statement that is for basically all the projects, layout projects that we do, is like we're not doing it without the scanning and the virtual twin ever again. So why is that bold statement? 3D and CAD work is done in the office, and it's best done in the office, right? And what the virtual twin really adds is the instant Gemba walk that you also can do over Teams. So even if I'm not at the same site, for instance, as the layout engineer, I can communicate through that tool with the layout engineer. We can together go into the model. We can take over. We can show each other. We can put in point of interest. I can make notes of what I want them to draw, how I want them to draw, what variants I want them to draw. It's just like really good. And then it's also, you can take instantaneously, you can take measures. So how big was that area? We're going to double the flow. How big will we need? Is that really enough? Is that good placed in our new environment? You can always go back, like really easy to do that. Quite often, especially when you're in production environment, or when you maybe also think about putting there another building or connect buildings in another way, there is walls and there is electrical installations and there is piping. And for us in logistics, there is HVAC under the roof. Maybe we want to do vertical shuttles or anything where we want to go in between some beams and stuff. It's just amazing what you can do, how fast you can go and say like, okay, it's not so good there. There is a lot of electrical installations. Maybe a door there will be very costly. But if we move the door there or there, it's like so much faster. It's so much faster. Gets so much more quality out of the whole thing. Yeah, and then last but not least, you can always compare your layout to the current setup that you have. So, and you can also explain why you have done certain things, and you can in a presentation setting with the customer go for a quick Gemba walk instantaneously in a workshop, in a presentation, when there is question. It's just like so much value for layout projects. Okay, that was kind of the fast forward presentation in how we use virtual twins and why we think virtual twin really made our job so much easier.
Excellent, thank you, Rito. Daniel, I believe, is there a second presentation? You're on mute.
Danny, you are on mute, so we can't hear you if you're talking.
Sorry about that. Not that I know of. I think there was a slot for just Q&A session or for a discussion. If there are some questions or if there are some discussions that wants to be raised by the audience. I don't know if there are any questions that have popped up or ideas or thoughts or.
There's nothing in the chat, but if anyone has any questions, now's the time to ask, please.
Yeah, just a comment from Johan. It was a great presentation. Thank you so much. And I was checking one of the comments because we started as well doing this warehouse digital twins quite some time ago, and we also did it with the Unity as a front or a environment where we put in the digital model and combine it with some BI tools, etc. What kind of tools are you using? Are you doing the CAD part of it, or doing it in CAD and then implementing it to something internal, or are your thoughts? It's going to close the door.
I think Rito, from your side, where you're at the moment, you're in the Unity world, right? So it's sort of like a gaming engine.
Yeah,
correctly. So
okay.
So yeah, what we did there is now for the time being we only have manual racking, but we have kind of a full racking configurator in Unity, so that you're very fast. So a normal warehouse layout is approximately 10 to 15 minutes to set up, including all the aisles and the areas where forklifts are allowed to drive, which we then combine together with information from warehouse management system and also directly from the Unity model, then create an environment where we can do discrete event simulation, which we feed into an AI tool, basically doing optimizations. So we are working very hard on standardizing the components in warehouses to Unity.
And just a comment there, Johan, from our side. I mean, when of course we're using this type of technology a lot in projects towards customers, or in some cases we have companies that are actually not going or not taking it as far as to have that 3D digital version of it. In other words, a CAD model, or whether it be Unity or any other type of CAD model. So they're actually still working with it in terms of collaboration, but in a web-based environment.
Yeah.
But it's a good question. I mean, it's an excellent question.
Yeah, I think it's because we started off in a little bit different way with taking it from the system itself rather than actually look at reality from the start.
Yep.
And I think you're very much right, or at least it's the same understanding that I have, that you take one step first and then you have somebody rebuilding the plant without actually importing data, and then the overlaid data looks quite strange when it's not matching the digital model.
Right.
I think that'll be quite interesting to see if what will happen in the future.
And I think just on that topic, Johan, I think that's one of the areas where a lot of research is going on. Where are we heading in the future? I mean, today there's still a limitation, I would say, in one way, depending on how you're using it. But as I mentioned, if you're working with 3D scanning, the limitation is the fact that you're only capturing the world, your factory, at that specific point of time. In other words, if you continuously 3D scan, around the clock, 24 hours a day, 365 days a year, I think that then we're talking. And personally, I believe that's where we're heading. It might not be here now. Of course, there are. I mean, if you look around a bit, there are ways where you have you can actually put a 3D scanning equipment on top of one of these dogs from Boston Dynamics that's continuously walking around, or you put it on top of an AMR or AGV that is you're scanning in 3 times. But I don't think that we're really there at the moment. But I think that's the direction that the technology development is going in.
Yeah, and maybe just comparing what they see in the new snapshot against the old one. So, but did you just one comment? When you make the scan, it's a point cloud. What do you think of the application that converts the point cloud to actual virtual objects?
The dream would be to be able to press a button.
We're not there
and then
yet.
get the
I'm not sure.
The virtual objects automatically, automatically made. Once again, I think the technology is heading into that direction. There are, functions, features that can help you to generate the virtual objects. But is it a one, press button action today? No, I would not say that. I mean, it's still some manual work where you actually have to, depending also, of course, what detail level you're looking at. So it's very much depending on the detail level. I think we have. I just looked in. I think we have Mr. Don Lee with us. That I know pretty well from the Volvo days, or from Volvo Cars. And Don, you're responsible for the 3D scanning activities at Volvo Cars. And have
a question here.
Yeah.
And also a follow-up of Johan. We have explored a collaboration with a startup that creates an AI that can maybe do that magic button. Of course, it needs to process like for a day or two before you get all the models, but it's an expensive button.
Yeah, and I think also, I mean, what we have to remember, Don and Johan and everyone else, is the fact that not every company is working with the same IT infrastructure. With that said, I mean that in some cases, depending on the file formats that you want to generate on the virtual side, how do you want to generate, and in what format do you want to generate? Of course, there are neutral formats and so on that can be generated in, but depending on who the consumer is and who it is that will actually use the information in the next step, I think it differs quite a bit from company to company.
My question that I also wrote in the chat is, I think, related both what you mentioned earlier, Daniel, and also what Reto showed in the presentation, that the different steps of making the 3D scanning, then getting into models, and then getting to the next application and using it, etc. But this is 3D scanning in a sense, it's just data gathering, and we would like to get as fast as possible to the stage when we're simulating or analyzing or layout planning with that data. So my question maybe is quite simple: how much can be automated, and how, with regards to current and future technologies that you see?
Yeah, I mean, I have a little bit to take from the logistics point of view. Basically, you know, that expensive button you talked about, to basically get to the model of the racking. Racking, you're normally not rebuilding every day, and it's very fast in basically modeling a warehouse and relevant parts of the warehouse in 3D. But what we basically add to our digital twin is semantics of racking, and basically the creation of that to make that very friendly, so that you can have large language models like ChatGPT interacting with that. So what we already can do now is basically getting a prompt where you can interface to ChatGPT, and ChatGPT will then, from your normal language, basically draw racking, right? But the next step for us, basically, there will be, or the interesting step will be for us, we're running discrete event simulation in our models that we generate, right? So we can see collision, how often you will meet other forklifts, what edges you often meet for forklifts, and all of that. So giving basically semantics to the object in your layout will enable AI to then try other layouts and change your layouts given the data and transactional data that you actually have, and statistics that you have in your from your other systems, to then basically alter a layout and simulate a layout and see, is it actually better? And AI will be able to do that very, very quick, much faster than what we humans ever could do it, and it can do it day and night. And that's where I see is kind of our company will probably be there for manual warehousing in 1 year time, that we basically can give a building, can give transactional data from the warehouse management system, and then actually let AI design a warehouse. So that's kind of the small revolution that we are working on. But then, of course, everyday operations, right? Making better decisions with AI is a big thing. So we see in manual warehousing, we can save between 20 and 40% of picking time in manual warehousing, which is like really huge, by making better decisions on where to place items and what picking strategies to apply to the items.
And just to add another take on that, on your question there, Dawn, I think we have, of course, we all have to have faith in the technology development, right? And if we agree that when you're actually scanning, I mean, you're just capturing data, and if we look at the evolution of scanning, I mean, if we go back 10, 15, 20 years, and if we just look at the amount of time and processing capacity that it takes then versus now, I mean, amazing progress has been made. In other words, today you can actually capture the data or 3D scan a factory so much quicker and so much cheaper than you could 10, 15 years ago. And I would say that the quality is better today also. So, and that's whether I mean, it's not automatic, but in some cases, I mean, it's becoming more and more semi-automatic. So it's, I think it'll be fun to see what the future has in mind.
Thank you for your answers.
Yeah, I mean, there, Daniel, to maybe turn it around. I see the future basically where every change first will happen virtually. So you never need to go back and scan, because it's basically you have already done it in your models, and the reality will follow. It's kind of that mindset that I try to have.
Yeah, oh, I definitely agree with you.
So
I will write
virtual
that down.
master, essentially.
Good. Any other questions or thoughts or ideas?
No, I think all the questions have been answered. I think it's been a really good conversation at the end, so really positive. So if everyone's happy, I mean, we've done all right. We're just hitting 58 minutes of a 1 hour webinar, so pretty positive on that front. I'm going to stop the recording there. Unless anyone has a quick question, put your hands up in 3, 2, 1, and there we go.